Hello, today we're going to cover Unit 1, Lesson 8, and this is Introduction to Parent Functions. We're going to start with the quadratic parent function, y equals x squared, and then move on to absolute value and square root functions. All of this information can be done on Desmos, but I feel like in order for you to understand what the graphs and the equations are showing you in Desmos, you need to understand this background information. So that's the purpose of this lesson. After today, pretty much all of this we're going to do on Desmos, but you need to be able to interpret your equations in case Desmos either isn't available, or maybe they give you a graph instead of an equation. You need to be able to understand what that graph means and how it relates to the equation. Desmos doesn't help you do that, so you have to have that understanding on your own. Okay, so basically what we're going to do, the parent function of a quadratic function is y equals x squared. And the quadratic function has something called graphing form, or vertex form, some books will call it. So graphing form, let me just write that up here, is y equals a times x minus h squared plus k. Now, when you have an equation that looks like this, a is going to be a number in front of your parentheses. X and y are the x, y coordinates of the ordered pair. H and k are going to be the vertex. They're going to form the vertex of your parabola, because if a quadratic function will be in the shape of a parabola, it will either be up and down like that, it's a U shape, or so it will go up like that, or it will go down like this. Now, there is a sideways parabola we will learn later when we do conics, but for now, all we're going to learn, at least in the Algebra 2 class, is up and down parabolas. Now, it will go up in this direction, an upward direction, if your a value is positive. It will go in a downward direction if your a value is negative. Okay, now if you look at this right here, that is in graphing form, but we don't have the a, we don't have the h, we don't have the k actually written out. So let me show you what that would be written as if it were actually in graphing form. It would be y equals 1 times x minus 0 squared plus 0. So basically what this one is telling me is 0, 0, 0 is my h, 0 is my k. So 0, 0, the point 0, 0 is my vertex of this parabola, and 1 is my a value. Okay? Whenever your vertex is 0, 0, and 1 is your a value, your parabola is the actual parent function, your quadratic. So this is the parent function equation for a quadratic. So if we were to graph that, back in Algebra 1, you should have learned that if you need to graph any kind of a function, well, you could choose numbers for x, plug those numbers in and solve for y, and that will give you a set of ordered pairs. So that's what we're going to do here. We're going to plug numbers in for x, solve them to get our numbers for y, and we're going to look at what that tells us the graph should do. To see what the graph of this parent function looks like, I'm going to choose values for x. Now, keep in mind, you know a parabola is going up and down because our a value is positive. We also said that the vertex of this parabola will be at 0, 0. So if we know that bit of information now, we know that part of this parabola is going to be to the right of the origin, part of it is going to be to the left of the origin. Whenever I'm plugging numbers into a graph to figure out what the graph will look like, there are some certain things I always choose. I always choose some negative numbers, I always choose 0, and I always choose some positive numbers. So that's what I'm going to do. I'm going to start with -3, -2, -1, 0, 1, 2, and 3. And again, all this can be done in Desmos, but the purpose of me showing you this is so that you understand where these ordered pairs that are going to be showing up in Desmos are coming from. It's really important that you understand that for some of the work we're going to do later. So what I'm going to do is I'm going to plug these numbers in. -3 goes in for x. Well, -3 squared is positive 9. So that gives me the ordered pair -3, 9. -2 goes in for x. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. That shouldn't be new. That should be old information that you already know how to do. Then at this point, we're going to graph those ordered pairs. So I'm going to go over here to my graph. -3, 9. I start at the origin. I go left 3, up 9. -2, 4. I go left 2, up 4. -1, 1. Left 1, up 1. 0, 0 is the origin. 1, 1, I go right 1, up 1. 2, 4, right 2, up 4. 3, 9, right 3, up 9. And so this parabola is my parent function of a quadratic equation. So there is my parent function of a parabola. Now, the next thing we need to understand is what happens to this graph. How is this graph going to change its shape if we do some different things to our equation? Like, what happens if we put a negative in front? What happens if we put a number between 0 and 1 in front, or maybe the absolute value between 0 and 1? So it could be positive or negative. What happens if we have things in this form and we actually have numbers other than 0 and 0 for h and k? What's going to happen to the graph? And that's where our dilations and translations come in to play with these. So we're going to talk about how putting other numbers in there affect what our parent function looks like. So I will keep the parent function up here so that we can compare what it looks like to our other functions. And what I would encourage you to do is maybe put this function in Desmos, and then you, as I'm doing them up here and you're taking your notes, you could put your functions in Desmos, the ones that we're doing, so that you don't have to do everything by hand, but you can compare and see the correlation between the equation and what the graph looks like. That's extremely important that you have that connection, you understand that relationship. I have kept my parent function graph up here. This is the graph y equals x squared. I'll write that up there so we can understand which one's which. And then I have 4 other graphs over here that we're going to do XY charts for. And we're going to compare what these graphs look like and compare them to the parent function. I'm going to use a different color marker for each of these so that you can compare what those look like with up here and understand which ones go together. So I'm going to do the same thing. I'm going to choose some negatives, 0, and some positives here. And I'm just going to go ahead and choose, I'm going to start at -2, do -1, 0, 1, and 2. And keep in mind, I'm squaring each x value, and then I'm going to multiply the square of each number by 2. So my numbers are going to get pretty big pretty quickly. So I'm choosing small numbers here so that I don't go way off the graph, so I can kind of see what's going on. So if I plug in -2, -2 squared is 4. 4 times 2 is 8. -1 squared is 1. 1 times 2 is 2. 0 squared is 0. 2 times 0 is 0. 1 squared is 1. 2 times 1 is 2. 2 squared is 4. 2 times 4 is 8. So those are my ordered pairs for y equals 2x. So what we're looking at is what happens to the parent function when we multiply the x squared, or my a value in front of the x squared, is a whole number larger than 1. Okay, so let's look at that. Negative 2, 8. So you'll notice here, 0, 0 is still going to be my vertex. So that point they have in common. So negative 2, 8. I go left 2, up 8. Negative 1, 2. 1, 2, and 2, 8. So if you look at this, it is still a parabola, meaning it's U-shaped. It's still going in an upward direction. But what has happened to my parabola? My parent function was the black function here. It starts this shape. But then notice, when I put a 2 in front, a whole number in front, or I could be more specific and say a number bigger than 1 in front of A, my parabola actually gets more narrow, thinner, skinnier, however you want to describe it, okay? So the parent function is it is wider than the function that's been multiplied by a whole number bigger than 1. So let's see what happens when we put a fraction in front between 0 and 1. Now, hopefully you understand that number in front of x squared is still positive. So it is still going to go up. In fact, all of these parabolas are going to go in an upward direction because we said if the number in front of x squared is positive, it is an upward parabola. We'll deal with the negative ones in a few minutes so that you can see how that works. So I'm going to choose some numbers here. I know I'm going to choose 0. I know I'm going to choose some negatives and some positives. But now let's think about it. If I choose odd numbers, won't I get a fraction? So I'm going to try to avoid fractions anytime I can. Now, sometimes you can't. Sometimes there's no way around it. You're going to end up with fractions as your y value. But anytime I can avoid it, I'm going to make my graphing a little bit easier. So I'm going to choose negative 2 and negative 4 and see what happens. And then 2 and 4 and see what happens as I graph those. So if I plug in negative 4, negative 4 squared is 16. 16 times 1/2 is 8. Negative 2 squared is 4. 4 times 1/2 is 2. Plug 0 in, we get 0. 2 squared is 4 times 1/2 is 2. 4 squared is 16 times 1/2 is 8. So if I graph that, I've got negative 4, 8. Negative 2, 2. 0, 0 is still our vertex. 2, 2. And 4, 8. So here is the parabola that we have when we multiply by a fraction between 0 and 1. What's happened? Well, remember, our parent function is still the black function here. So our blue function, that is the function where we have multiplied by a number or a fraction between 0 and 1. It has gotten wider than the parent function. In fact, that will always happen. When your a value is between, I'll say between negative 1 and 1, your function will get wider than the parent function. Very important. Okay, so now, knowing what you know about these two functions, what would you predict are going to happen for those two functions, the y equals 5x squared and the y equals 1/4 x squared? What do you think would happen? Hopefully you're saying that the y equals 5x squared would be very narrow and that the y equals 1/4 x squared would be wider than the parent function. So what I want you to do now is go ahead and graph both of those and see if your prediction is true, and I will put them up here and we'll compare what we got. As you do that, don't delete any of the functions if you're doing it on Desmos. Keep them all on there so that you can compare them all on the same grid. Okay, so I have finished the y equals 5x squared. I've done that one in green, and you can see here It is very narrow, which is what we would expect with a whole number in front of the x squared term. And then the y equals 1/4 x squared. Notice I picked even numbers again because I wanted to try and make sure I didn't end up with any fractions. And that one is the brown one out here. My marker was a little faded. I'm not sure how well that showed up. But you can see that one is very wide. So our prediction holds true. Whole numbers in front cause them to be very narrow. Fractions in front cause them to be wider. Notice here also, I want to point out, when I choose numbers for x squared here, when my number in front is 5, if you think about that, I'm choosing numbers for x and then squaring them and then multiplying that number by 5. My numbers get extremely big very quickly. So even picking something like -2 made my number go huge. So that is one good thing about Desmos and not doing them by hand, because Desmos is a lot easier to decipher what your points are because you can do larger graphs on that program. So that is one benefit to having something like Desmos over maybe a graphing calculator, because on a calculator sometimes you can't tell where those numbers are without hitting a trace button or something like that to see exactly where that ordered pair is. So I think that is one good thing about Desmos, and that's one reason that I think it's an improvement over the graphing calculator. In this segment, I want to make sure you understand what happens if we have a negative in front of our x squared term, because that will make the graph look completely different. Now, remember, when you have a negative in front, that just means you have a -1 in front of your function. So I'm going to choose numbers just like I did before. So I'm going to do -2, -1, 0, 1, and 2. And I'm just going to plug those numbers in. So when I plug in -2, I get -2 squared is 4 times -1 is -4. -1 squared is 1 times -1 is -1. 0 squared is 0 times -1 is 0. 1 squared is 1 times -1 is -1. And so if we look at what that does to our graph, we start at 0, 0, we go left 2, down 4, left 1, down 1, 0, 0 is our vertex, right 1, down 1, right 2, down 4. And I could have chosen some more numbers, but I think you probably see what is happening here. We have a parabola that is going down. It's in a downward motion, and that's what we said would happen when we put a -a in front of our x squared. So here our a value is -1. So if you look at this, putting a negative in front of the x squared actually flips that function across the x-axis. Okay, so that is a flip, one of our transformations that we learned in geometry. Okay, and one thing I didn't mention before, all of these that were up here were dilations. They're getting wider and thinner. They're dilations. Now let's talk about what happens if I have a negative in front of the x squared. Go ahead and predict what you think might happen there. There's a negative in front of the x squared, and that negative number is a fraction between 0 and 1. And go ahead and predict what happens when we have a negative whole number in front of your x squared there. What do you think would happen there? So go ahead and do those either in Desmos or by hand, whatever you prefer, and see if your prediction is true. Okay, so remember, we had our parent function here. What happens when we multiply that parent function by a negative is we ended up with this red graph here. There's a -a in front, -1a. So it's basically the parent function flipped upside down. And then I ask you to graph these to see if your prediction was true. My prediction for this is that it's going to go down because it's a negative, and that it's going to be a wider function. So I did that one in blue. If you look here at the blue one, these are the points that correspond with the ones that I chose there. So in fact, it is wider than the red function, okay? For this one, negative, I'm predicting it's going to go down, and then it'll be narrower than the red function. And in fact, that is what happens. It's here in green. And so you can predict based on the a value in front what's going to happen to your graph. Earlier in the video, I had mentioned graphing form of a quadratic function. And we had mentioned that whatever h and k are in the function, that would be your vertex. So we need to understand how to interpret how h and k change where the vertex is in the position of the graph. Okay, now we still do this based on the parent function. Okay, now one thing you need to understand is if the number in front of your x part of the equation, so if the number in front here is a 1, it will be the same shape as your parent function here. So one thing you need to understand about the parent function is if the origin 0, 0 is your vertex and it's a parent function, then to get to the next point, you're going to go right 1, up 1. To get to the second point, you go right 2, up 4. To get to the third, right 3, up 9. As long as you know your square numbers and you know that a parabola has symmetry, in other words, my first point is 1, 1, and I can use symmetry to get the next point. This parabola, if the vertex is at 0, 0, the axis of symmetry is about the y-axis. So it goes 1 from the right of the axis, 1 to the left of the axis would be another point on the parabola. For 2, 4, this point is 2 to the right of the axis of symmetry, so 2 to the left of the axis of symmetry would give us another point. So we can use symmetry, as long as we know the right-hand side of the parabola, we can use symmetry to get the left-hand side of the parabola, which is very convenient when we have something in graphing form. Because as long as we know where the vertex is, if A is 1, then our parabola is going to be very easy to graph. Now, when A is not 1, it's not quite as easy, but we have Desmos to tackle that. So that is another good thing, our graphing calculator to tackle that. We will be able to tell whether it's thin or wide. And other than that, there's really not a whole lot of detail we need to go into that until we get into pre-cal. Okay? So if I give you something in this form and A is 1, okay, then it's fairly easy to graph as long as we understand that H and K help us represent the vertex of my parabola. So now I'm just going to randomly pick, let's see, I'm going to say y equals 1 times x minus, I'll say 2 squared plus, I'll just say 1. Okay? There's my new parabola. And what I'm going to do is I'm going to do an XY chart, and we're going to try and figure out some values for that parabola. Now, I'm still going to choose, since I know this is a parabola, I'm still going to choose some positives, some negatives, and 0. So I'll choose 0, -1, -2, and 1 and 2. When I put them in my XY chart, I always tend to put them in numerical order. You don't necessarily have to. You'd still get the same thing regardless, but I just like to put them in numerical order. So now, let's see what happens when we plug numbers in. And then we're going to make some connections between these. And maybe I should do this. Let me do this in a different color so that you can compare the parent function that is in black with the new function that will be in red. All right, so if I plug in -2 for x, -2 minus 2 is -4. -4 squared is 16 plus 1 is 17. Well, that one's going to go off our grid, so we probably won't be able to graph that one, but we will at least be able to tell kind of what it looks like as we continue forward. If I plug in -1, -1 minus 2 is -3. -3 squared is 9 plus 1 is 10. If I plug in 0, 0 minus 2 is -2 squared is 4 plus 1 is 5. If I plug in 1, 1 minus 2 is negative 1. Negative 1 squared is 1, plus 1 is 2. And if I plug in 2, 2 minus 2 is 0. 0 squared is 0, plus 1 is 1. Now, if we look at this, let's see. I've got, well, negative 2, 17, that's way too big. We can't really graph that. Negative 1, 10 is here. 0, 5. 1, 2. 2, 1. Well, look at what's happening. That's all the points I have. We know this has got to be a parabola that's shaped like this. Because the a value is 1, we know it's going to be this thickness, because if it weren't that thickness, we would either have a whole number to make it thinner or a fraction to make it wider, okay? So we know it has to be this shape, but it looks to me like we're only getting one side of that parabola. So we've got to see what's happening on the other side by going a little bit further. Now it looks to me like this is the left side. So it looks to me like I need to continue to put some points in there that are on the right side of this to figure out where this thing is going. So let's do that. I'm going to just continue and I'll just do 2 more points, 3 and 4, and let's see what happens. So if I plug 3 in, 3 minus 2 is 1, 1 squared is 1, plus 1 is 2. 4 minus 2 is 2, squared is 4, plus 1 is 5. Well, now look at this. My numbers are starting to repeat. So that tells me that I'm probably getting the other side of the parabola here. 3, 2, right? 3 up 2. And look at that. You can see it has done the curve. And 4, 5. So it looks to me like my vertex is right here at 2, 1. And I could draw, hopefully you can see this, I'm not in the way. Oops. I'll do the best I can as far as it goes up pretty high. It's going here. And we know it's going to continue. Now, how can I figure out what this point is without having to do a bunch more math? Well, I can use symmetry. That's my vertex. See that? So if that's my vertex, this point is 1, 2, 3 from the axis of symmetry. So 1, 2, 3 on the other side gives me that point on the other side. And look at how my parabola has changed, okay? It's still the basic shape. It's still the same width. It's not any narrower or wider because the a value is 1. But look at what has happened to my ordered pairs. At 0, 0, my vertex has moved right to up 1. Look at this. There must be something significant about those numbers if this is happening. My original vertex for my parent function was at 0, 0, but this one, the vertex is at 2, 1. Now, I mentioned before that HK helps you find your vertex of your parabola. So there's a connection here that we need to look at, okay? And we'll come back and look at that in just a minute. So this one I'm going to write up here is y equals x minus 2 squared plus 1. All right, now I'm going to try another function. And we're going to do the same thing and see what happens with this function. I'll do this one in blue. So let's do y equals, and I'm still going to make my a 1. I'll say this time x plus 3 squared minus 2. Let's see what happens with that. So I'm going to do an XY chart. I'm still going to try the same numbers. And let's see what happens. If I plug in negative 2, negative 2 plus 3 is 1, 1 squared is 1, 1 minus 2 is negative 1. If I plug in negative 1, negative 1 plus 3 is 2, 2 squared is 4, minus 2 is 2. 0 plus 3 is 3, squared is 9, minus 2 is 7. 1 plus 3 is 4, squared is 16, minus 2 is 14. Looks like my numbers are getting bigger than I need here. 2 plus 3 is 5. 25 minus 2 is 23. So really, when I get to this point, I'm not going to be able to graph those anymore. But let's see what that looks like. Let's see, negative 2, 1, or I'm sorry, negative 2, negative 1, negative 1, 2, 0, 7. So it looks to me like maybe we have the right-hand side, but not the left-hand side. So if I have these numbers, I need to pick some more numbers for x that are to the left of negative 2. All right, so these didn't really do me any good. I'm not going to go any further with positive numbers. But let's look at what happens if I do some more negatives, like negative 3, negative 4, and maybe negative 5. I'll just do 3 more and see what happens. So negative 3 plus 3 is 0, squared is 0, minus 2 is negative 2. Negative 4 plus 3 is negative 1, squared is 1, minus 2 is negative 1. Negative 5 plus 3 is negative 2, squared is 4, minus 2 is 2. And look, we have some numbers here that are repeating, so that's a good sign. So if I do negative 3, negative 2, that's right here. And negative 4, negative 1. Oh, it looks like we've got some symmetry starting here. So this must be our vertex, because that must be our axis of symmetry. And I bet if this is our axis of symmetry, that's 2 over. I bet negative 5, 2 is a point. Yes, it is. Okay. Negative 4, so we've got them all. So if this is my axis of symmetry right here, this is 3 from the axis of symmetry. 3 on the other side will give me my other number. And then we can graph our parabola. And again, you could put this on Desmos. Whoops, and compare those graphs as well. But I think it's important for you to understand where these ordered pairs are coming from. If you don't understand how to plug into the function, then that hurts you algebraically later. If you're not thinking about that type thing, later on when I'm trying to get you to write equations for different things, and maybe all I give you is the vertex and an ordered pair on the parabola, and ask you to put it in vertex form, if you don't understand this process, that is not going to make sense to you. So I think it's important for you to get this. Okay, here is the new parabola. Now look at it. It is the same width as this one. Okay, so it's not any thicker, which tells me A is 1, right? From our vertex, we go right 1 up 1, right 2 up 4, right 3 up 9. So you can see that we still have the same basic shape as the parent function. Look at where the vertex is. That is the important thing. It looks like our vertex, the original and the parent function was at 0, 0, but this new vertex, we're going left 3 down 2. Left 3 down 2. Now before, this one went right 2 up 1. This one went left 3 down 2. There's a connection here that we need to make, okay? The h value is going to be the x coordinate of the ordered pair. Now notice in the graphing form, this is a minus. So if this is a minus, we're using the positive 2. But if this is a plus, the sign has changed, our x value will be a negative. The vertex in this function was at 2, 1. The vertex at this blue function was at negative 3, negative 2. So let's make this connection. Whatever this number is going to be our x value, okay? If there's a minus in front, I guess you could say if it's a negative 2, then the x value will be positive, opposite. If it's a positive 3, our x value will be negative, opposite. Look at our y values. This was plus 1, our y is plus 1. This is not minus 2, our y is minus 2. Okay, so your x value will be the opposite of what was in parentheses. your y value will be the same as what was outside the parentheses. And this is where, or how we're going to use the graph, or the equation, to figure out our vertex very easily, okay? So, if you think about this, this is representing a slide. Let's look at the red function in comparison to the black function. Our origin was at 0, 0 in the parent function, but here the origin moved right to up 1. This entire parabola has a slide, or a translation, that is going right to up 1. This point 1, 1, right to up 1. There it is. The point 2, 4, right to up 1. There it is. So every single point on the black is transforming to the red by using the translation right to up 1. Look at this one. We said -3, -2 would be our vertex. So it looks like this is a slide. Left 3, down 2. Every single point, left 3, down 2. On this parabola, left 3, down 2, has that same slide that we can find based on this information. So the vertex is what we get using these two ordered pairs, or these two numbers, the h and the k. That will give us the vertex. And then, as long as we have a is 1, we know that wherever we put the vertex, from there we can go right 1 up 1, right 2 up 4. We can use symmetry for the axis of symmetry to get the other half of the parabola and draw it. It makes it really simple to draw these by hand. It also makes it really simple, if you're given a graph, to come up with the equation. So I have 3 more examples. If you're going to do these in Desmos, that's fine. But I want you to look at these, come up with what the vertex would be, and predict where your vertex is supposed to be in your graph before you put it into Desmos. It's very important that you understand that. Now, looking at the blue function, your vertex, the x value is opposite of what this is. So that would be a -2. The y value is the same as what this is, -5. So my vertex is going to be -2, -5. And I'm just going to show you how to graph this without doing an XY chart. I think it's a lot easier and it's a lot faster. The a value was positive, so we know it's going up. And then from my vertex, we know the a was 1. If the a is 1, it's a standard parabola. So from the vertex, we go right 1 up 1, right 2 up 4, right 3 up 9, and then that gives us the right-hand side of our parabola. And then we can use symmetry for the other side. The axis of symmetry, remember, is the vertical line that goes through the vertex. And so here is my, I'll just draw it in here. This is my axis of symmetry, this x equals -2 line. So -1, or that's 1 to the right, so 1 to the left. 2 to the right, we go 2 to the left. 3 to the right, we go 3 to the left of that axis of symmetry. And that draws, or shows us, the left-hand side of that parabola. Okay? So that's how we would graph, given an equation. We find the vertex. We know it's a standard parabola with 1, so it's a standard width. And then we go from there. Now, if it's not a standard width, you can still answer some questions about that graph without graphing it. But I would use Desmos to graph it. If we do that one, trying to find the vertex, well, the x value is opposite what that is, so 1. The y value is the same as that number, 1, 3. So my vertex for this one will be at 1, 3. It's a standard size parabola, so for my right-hand side, I go right 1 up 1, right 2 up 4. I could go right 3 up 9, but I think I'm going to run out of room, which is okay. You can do it with 5 points. Axis of symmetry would be through the vertex, that vertical line through the vertex, so x equals 1 for our axis of symmetry. And then I use symmetry to get the other side. There's the other side, and I graph my parabola. Okay, and if you put it in Desmos, it should give you the same thing. Now, look at the third one. What do you notice is different? Hopefully you're seeing that's a negative, okay? All that does is it doesn't change the size of the parabola, it flips the parabola, okay? So it's going to flip it upside down. I can find my vertex the same way I found it up here. That's not going to change. So my vertex here is opposite this number for your x, so -2. Same number here, -1. So from 0, 0, I'm going to go left 2, down 1. We know it's going down. So now normally we would go right 1, up 1, but this negative in front tells us instead of going right 1, up 1, I'm going to go right 1, down 1, and right 2, down 4. Then I'm going to use symmetry. This is my axis of symmetry at x equals -2. So 1 to the right would be another 1 to the left. This one is 2 to the right, so I'm going to go 2 to the left. And that gives me my new parabola. Notice it's facing down, okay? So here's what you need to take from this. Anytime you have something in vertex form, and this is always going to be true, whatever is inside the parenthesis is going in the opposite direction of what the sign says. And whatever is inside is going to move left or right. Opposite what you would think. So if it's a +2, it's going to move left. If it's a -1, it will move right. So this one, +2 means it moves left 2. -1 means it moves right 1. +2 means it moves left 2. So whatever's inside tells you whether to go right or left, opposite of what you would think based on the sign. Whatever is on the outside tells you whether to go up or down. The same as what you would think. So if it's a minus on the outside, you're going down. If it's a positive on the outside, you go up. If it's a minus, down. Okay, so this one is telling me to go left 2, down 5 from my parent function vertex. This one is telling me to go left 1, up 3 from my parent function vertex. If you know that, and this is either 1 or -1, you can graph your new function or your new parabola very easily. Now, why am I being so detailed about this? Because parent functions for other graphs work exactly the same way. Whatever is on the inside tells you to go right or left, opposite what you would think. Whatever is outside tells you to go up or down, opposite of what you would think. So, as we're going through different functions throughout the year, that will never change. You are going to see that over and over and over again. And in Algebra 2, that is one of the main things you need to take from Algebra 2. Because when you get to pre-cal and calculus, you have to be able to graph this stuff quickly. Okay? And knowing that little bit of information is going to really help you graph things and interpret graphs quickly. And that's extremely important as you head forward.